So, David, we started with the video. We talked about animation in general and their purpose and how to get them right. And then we discussed a bit about the fact that animations, sometimes you need to do tricks to make animations look right and fluid. First, let's start with the problem. Okay, what is the problem that we're trying to solve?
So the big problem is layout animations. That's one of the most commonly requested animations where you want parts of the web page, whether it's a small part or a big part, to smoothly transition from one point to the other points. And you might think that's pretty straightforward, just animate left or animate width or animate height. But the problem is that animating those properties aren't very performant.
Can I just first ask you to give me an example so that we use this example throughout the explanation, an example of a layout that you want to animate?
Oh, there's many examples. I think one of the common ones is if you go on your mobile phone and you look at your Photos app, if you tap a photo, it doesn't just show up out of nowhere. It smoothly animates from its small tile to a bigger view, and then you could collapse it right back down.
Okay, and that's why you call it layout animation.
Right, because you're changing both the left, top, width, height, so all of the layout properties.
Right. So now the problem you're saying when animating layout is performance problem.
Right.
Why is that?
So performance is a problem because when you animate left, top, width, and height, CSS on every single tick is going to do a layout recalculation. And what that means is that when you adjust the layout, it's going to see what are the elements next to it. Okay, I have to figure out the positions of them. Even if the elements might not affect anything else, CSS and the DOM is still going to check all of those elements again to see, did the layout change? Do I have to change anything else?
Right. And how to do about it. So basically you're saying if we're using width, like all these position properties, they affect layouts.
They do.
They're supposed to, and that's why CSS has to absolutely calculate that.
Right, yeah. Like for example, think about block layout. When you change the height of something, it might push something down.
Right.
So not only does this need to be recalculated, but any element next to it needs to be recalculated.
And you're
too.
saying even if there is nothing after it,
right,
the calculation has to be done anyway to say like,
slow.
okay, nothing.
Exactly. Yeah.
And why is that a problem? Is it like it will not be able to handle it, or what will happen if we use it? What we will see?
So if you do it with a small website with not too many elements, the answer is not much. You might still get a smooth 60 frames per second animation. However,
so 60 frames per second is important to get.
60 frames per second is important because that's the natural refresh rate of a monitor, and so everything is smooth at 60. That's like your smooth rate right there. But when we have a website with a lot of elements and a lot of things laid out, then we typically will not get that 60 frames per second just because there's so many calculations occurring behind the scenes in order to figure out the layout of all of the adjacent elements.
So like imagine like it's on one of the frames of the 60, the 25th frame, and now it's calculating. And it's taking too long. What will happen there?
It'll skip a frame.
I will skip it completely, the frame. Okay.
And you will notice. I promise you will notice, because you will notice that, it's not as smooth. Yeah, just like you notice if there's a scratch on your car, you're going to notice if there's a skipped frame.
Right.
Yeah.
So now, okay, we understand the problem. How to do about it?
So what we could do is use two properties, opacity and transform. And the reason we use those properties is because instead of the CPU calculating the layouts for everything, now we're moving the elements to the GPU, which is the graphics processing unit. And so that's going to put it on a layer where it's like it's in its own magical world where you could change the scale, so not the width and height, but the scale X, the scale Y. You could do translate X, translate Y. You could do all of these what are called transform matrix operations on that element without affecting layout. So the layout's not even aware of what's going on.
Right, because transform does not impact the layout anyway.
Right. If you think about it like in a block layout or something like that, when you scale something or you transform it, everything else stays the same.
Okay.
Yeah.
So, and that's the trick. To if you use transform and opacity, you said, then will happen on the GPU, and it will not affect the layout, so you will not run into skipping these kind of frames.
Exactly. And so you could have very performant animations by only animating one of those two properties or both of them if you need to.
But now, isn't it limiting only having to use transform and opacity to do maybe some more complex? Like you tell me the photo to come from here to filling the layout.
You would think it's limiting, but with a few tricks, there's actually ways that you could accomplish a lot of animations with just those two.
So one of them you talked about is flip.
Yeah, so there's this flip technique, and I don't mean flipping like that, but it's an...
But the name is cool anyway.
Yeah, it is. It's an acronym coined by Paul Lewis over at Google a few years ago, or actually it's a mnemonic. It's F stands for first, L stands for last, I stands for invert, P stands for play. Yeah. And so the way it works is you have an element in one position, right? And then when your layout changes, first you measure what you keep measure of what is the first position of that element, and then you do the layout change or whatever, and your element's going to change. But right before it paints, you measure the last position. So now you have those two positions, first and last. So you could measure how far to the left or how far up or how big, how small did it become. You could do all those measurements. That's just, simple math. And then you invert it. So when the element's in its last position, now that you did those calculations, you could move it to its first position. So you're giving the illusion that it's still in its first position.
I see.
And then comes the play. So play means since you did all that inversion, just transform everything back to zero, and it's going to move to its final spot.
Right. So basically first you do the calculations of the first, the last position, and then you actually display the target layout, right? You don't display it, but you send it. But before rendering, you transform it into the initial one because you have the first position, you know where it is, and then you animate it back.
Exactly. Yeah.
Okay, nice trick. Now, can you give us examples of how can you use that for different for a concrete example?
So many different things. The photo gallery example, that applies to both the web and mobile. When you have a tile or a bunch, like a gallery of photos, you want to click one, you want to expand it. That's usually a common ask in a website. Like if you go on medium.com, those photos where if you click on it, it sort of expands to take the width of the screen, and then you click on it again, and then it shrinks back. So that would be an example of that.
So basically what you do here is that you get the target layout, and then you transform it back to the small state.
Right.
And then you animate it back to the big state.
And the reason you do that is because it's simpler to animate to zero. Because all you have to think about is just, remove all the transforms and everything will just go back to its normal position.
So you actually transform it and then let's say back to zero, the initial state, and it animates it back.
Yeah.
Okay.
Think of it like, have you ever played with those little sponges where you can make them really small, and then if you just drop it, it goes back to its normal size.
Yeah. Okay.
So it's just like that.
I like the metaphor. But now, does it only work when it's are there special cases that might seem complicated to do with the flip technique?
Yes, there are. So nested elements are a little bit of an issue, and that's because let's say that you have some content, like some text. So we're not just talking pictures here, and you want to sort of like grow it or shrink it or something. And so the container, that's going to grow or shrink or move somewhere. But when you do that, the content inside, even though that probably shouldn't change size because it's like text or something, what's going to happen is when you invert it, the text is going to be smushed or stretched or something like that. And so you want to avoid that. And so I talk about a trick where instead of inverting the entire element, you invert some sort of background element. So instead of just the text or like the entire element, the text stays alone. So the text is just going to move with the container element, but now you have a background element that grows and shrinks. and so you still have that illusion. So it's sort of like an illusion on top of an illusion.
Right.
Yeah.
So let me see. Like if you have imagine, is it the right example to say like if that photo gallery was text gallery?
Mm-hmm.
Okay, we had an element that had text, and we have to click on it, and then it moves and it becomes bigger. Is that a good example?
Sort of, yeah. So, or take a, here's an example. Take a button, right? You have a small button with text inside. And let's say that your designer wants this effect where when you click the button, it goes full width.
Okay.
Or like stretches or something.
Something like that.
It becomes bigger. So when you do the flip technique, you're going to have the bigger one. The text is going to stay the same size. Text is not going to change at all. But when you shrink it, now the text is going to be shrunken too.
Mm-hmm.
And so now you have to stretch the text and then you have to shrink it, and it becomes very confusing.
Yeah.
But if the button stays the same size, the text stays the same size, and the only thing you animate is some background element, then that's going to be
what could be the background content?
like a pseudo element, or you could put a div in there.
Right. Okay, I see.
Yeah.
Okay, so that's how you can manage that complexity.
Exactly.
By transforming another element, background element.
Yeah.
Any other cases that you think of that might be complicated with a flip technique?
Other things that might be complicated is rotation.
Mm-hmm.
So that one you have to do some matrix calculations, and that gets really hairy. But typically people aren't rotating things, or hopefully people aren't rotating things too much on the web. But for most use cases, the flip technique as is should work pretty well.
And do you have some kind of place or documentation resource where people can dig deeper into the flip technique?
Sure. Yeah. If you look at Paul Lewis's article on arrowtwist.com, he describes the flip technique in there. I wrote an article for CSS Tricks about it.
Mm-hmm.
We talk a lot about it on the keyframers, and I have a library called flipping.js, which I'm trying to release version 2 of it, which uses CSS variables to help manage those mathematical operations.
We should absolutely link them into the description of the
Sure.
video. Okay, cool. Well, I guess in the next video we'll talk about something how to reason about animations, and what are the techniques to help us reason about animations, not to have them chaotic if you have several animations.
Okay.
Thank you.
Thank you.